Welcome back. Today I'm going to be going over 2.7, which is our next lesson in this geometry course, and we're going to be focusing on transitive and substitution properties. If you haven't watched my previous video on multiplication and division, I highly recommend you do so, but I don't want to waste any more of your time, so let's get into it. So let's start with the transitive property, right? So transitive property of equality is essentially if you have a relationship where A equals B, right? Like the values of A and B are the same and B equals C. Therefore, with that chain of logic, you can say that A equals C, right? Think of it as similar to that drawing uh, conclusions, right? Where, well, if you know one thing is true, another thing is true, because those two are bridged by like B in this case, you can say that both of them are equal to each other. Now, of course, this is another theorem, right? You should know. Um, If segments or angles are congruent to the same segments or angles, they are congruent to each other. And another version of the transitive property, if segments or angles are congruent to congruent segments or angles, they are congruent to each other. And I'm going to explain what both of them are more in depth. So let's look at the first one, right? Imagine you have this scenario where angle A is congruent to angle B, and you have angle A is congruent to angle C. Well, you can generally like just conclude, right? If you just look at this, right? If A equals B, just think of it as equals, right? If A equals B and A equals C, right? Well, that means B and C also have to be equal to each other, right? Because the values are both paired to A, right? So therefore you can conclude that B is congruent to C. And the reason you can do that is because of the transitive property here, right? The first one, where if two angles, and I'm going to explain this actually, like let's look at the if part. If two angles are congruent to the same angle. So here angle B is congruent to angle A, right? And angle C is congruent to an angle A. So they're both congruent to angle A, which is the same angle. Then they are congruent to each other, right? So again, these angles are congruent to each other because they're both congruent to the same angle. So that's the first version of the transitive property. The second one has to do with congruent pairs. Let's imagine another scenario where you have angle 1 is congruent to angle 3, right? And angle 2 is congruent to angle 4, and 2 is congruent to 3, right? You have to conclude that you can conclude that angle 1 is congruent to angle 4. And if you're not sure why, right, there is a lot of congruency pairs going on, so it can be a bit confusing as to why you can make that conclusion. But I always like to visualize it, right? So they give us that 1 equals 3, right? So I've kind of displayed that here, that angle 1 is equal to angle 3. They tell us that angle 2 is equal to angle 4. Likewise, I've written that there. And of course, finally, they tell us that 2 is equal to 3, right? So I like to think of this as what other connection hasn't been made yet? Well, obviously this one, right? 1 and 4, they haven't been proven congruent, so that's the conclusion that you can make. And the reason is, right, once again, this is the second version of the transitive property. If two angles are congruent to congruent angles, right, they're congruent to each other. So in this case, the two angles, angle 1 and angle 4, they are congruent to congruent angles, right? They are congruent to angle 3 and angle 2, which are congruent to each other. So therefore, you can say that these are equal to each other. Okay, next up is the substitution property, right? And the reason I like to go over substitution too is because it's more of a general case. And I'll get to that. But if you have angle 1 uh, is complementary to angle 2, right? And you're also told that angle 2 is congruent to angle 3. Well, think about it like this, right? We're given that these two angles are equal, and we're given that angle 1 and 2 are complementary. Well, 2 and 1 have the same values, right? Therefore, you can actually say that angle 1 is also complementary to angle 3, right? Because again, these two, angle 1 and angle 2, um, so again, these two here have the same value, right? Angle 2 and angle 3 have the same value. So what you can effectively do is plug in angle 2 for angle 3, right? And say that angle 1 is complementary to angle 3. Once again, think of that as you're substituting the value of angle 2 uh, and putting it as angle 3, right? That's where the substitution comes from. So what is the difference between the two? Well, the substitution property is more general, right? Because you can substitute variables for any expression, right? Whereas in the transitive property, it's only one specific instance, right? And the difference is important to understand, right? And it'll make more sense as we do more proof questions. But usually, whenever you're dealing with congruency, you're most likely going to use the transitive property, and when you're using like equations, right, mathematical equations, and if you have complementary or supplementary angles, you're most likely going to use substitution. So yeah, that's just a good thing to know beforehand. Okay, let's look at some proof examples. So let's say you're given this diagram where you have FG is congruent to KJ, right? I'm going to indicate that in green here, right? So you have FG is congruent to KJ, and you're also told that GH is congruent to KJ. So those two are congruent too. So our end goal, right? Proving that line KG bisects FH, right? So we're proving that this line here bisects this segment. Well, using what I've indicated in the diagram, you can see there's overlap, right? There's two congruent pairs here, or yeah, there are two congruent pairs, but like these two segments are congruent to each other, and so are these two. And there's an overlap here. So that's, again, if you ever see an overlap in congruency, that's a good sign that you can use one of these properties that we just learned in this lesson. So in this case, right, we have to, of course, we write our givens down first, right? That's always the first step. Then after that, look at this, right? These segments here, they're both congruent to the same segment. Therefore, you can see that they're equal to each other, right? Sometimes just by looking at it in this form, it makes it much easier to understand, because you can obviously see that both of these are congruent to the same segment. So you can say that these are congruent to each other. And that's the third step, right? If two segments are congruent to the same segment, they are congruent to each other. And of course, now that we've proven that FG and GH are congruent to each other, right, we can jump right on to the last step, which is that FH is bisected, because, well, we've proven that they're congruent to each other, right? That means they're being divided in half by this line here, right? So use that definition of an angle bisector, or not an angle bisector, of a bisector, right? Which we learned previously. So again, right, you can say if a line divides a segment into two congruent segments, it bisects a segment, right? So once again, right, anytime you see overlapping kind of marks or symbols, when it comes to congruent pairs, it's a good sign that you're going to be using one of these properties. And again, in this case, we use the transitive property because I told you earlier, most of the time when you have congruency pairs, that's when you use transitive property. I'm going to be going over a substitution property example, right? Let's say you're given that angle 1 plus angle 2, right, equals 90 degrees, and that angle 1 is congruent to angle 3. And you're trying to prove that angle 3 plus angle 2 is 90. So once again, right, I mentioned this earlier, anytime you're dealing with mathematical equations, most likely you're going to be using substitution. So in this case, you're given these two pieces of information, and you're trying to prove angle 3 plus angle 2 equals 90. Well, I think that's a pretty simple conclusion to make, right? And it's pretty common sense, because here you know that angle 1 is equal to angle 3. So what you can do is you can substitute angle 3 for angle 1 here, and that's how you get the conclusion, right? So once again, right, in my opinion, that's pretty simple to understand. You write your givens down, and for number 3, you can just use, write that final statement in the reason, For reasons, you can actually, in this case, just put substitution property, right? There isn't like a specific theorem. You can just put that as a reason. And once again, if that doesn't make sense, you're substituting uh, the value of angle 1, right, and replacing it with angle 3, right? That's how you get this conclusion here. Think about this. If you have a plus b equals 90, you have a equals c, well then, because a equals c, or you can say c plus b equals 90. So that's a classic example of substitution in a proof. Here's another question. If you want to look at it again, right? Pause the video. This one will be a transitive property question or proof, but I want to go over this one. One example where you actually might not need to use either. Um, so here you're given that angle A is complementary to ADB, angle C is complementary to angle CDB, and that DB, ray DB bisects ADC. You're trying to prove A and C are congruent. So how do we approach this? Well, let's mark the diagram first, right? That's always the easiest step. So DB bisects angle ADC. So we have DB here that bisects this entire angle. Therefore, right, because of angle bisector, right, remember, we can say that these two are going to be congruent angles. And notice that I'm going to be using different colors, but again, just keep in mind that these are congruent to each other, right? Notice that that blue angle, right, is just angle ADB, right? And that green angle is just angle CDB. So, and we know that our end goal is to prove that those two are congruent to each other, right? Angle A and angle C. Well, if you go back to the theorem that we learned quite some time ago, you'll realize that, well, yeah, that makes sense, because think about this. You have both of these angles, right? And they're complementary to congruent angles, right? Because remember, these two are congruent. They're being bisected by a ray. So because both of these are complementary to congruent angles, we can say that these two are also congruent, right? And that has to do with congruent supplements and complements. If you haven't watched that lesson, that's where this comes from. So again, right, we have kind of thought that out, so let's write it. So our statement, again, all givens, right? So our first statement here, angle A is comp to angle ADB. Of course, DB bisects angle ADC. And you can say that all these are given, right? Our next step, well, let's start with that angle bisector, right? If DB bisects angle ADC, you can say that the blue angle, right, angle ADB is congruent to the green angle, which is angle CDB. The reason, once again, I encourage you to write the actual theorem down, but in this case, I'm just going to write angle bisector definition, right? So now that we've proven that, well, we can actually jump right towards the conclusion, say that angle A is congruent to angle C. The reason is, well, right, this goes back to congruent complements and supplements, right? If two angles are complementary to congruent angles, right? So in this case, angle A and angle C, they're complementary to those two angles, which are congruent, right? So they're complementary to congruent angles. If two angles are complementary to congruent angles, then they are congruent, right? And that's all you got to do. Now, you might be wondering, well, why did you not use substitution, right? You said that complementary means you use substitution also. I think you could, right? You could definitely use substitution. You got to recognize that there are different ways to solve proofs. I solved it this way just as a review for what we have learned already in the past. but you can definitely use substitution, right? Um, you can say because angle ADB is congruent to angle CDB. In this case, right, those two here, right? You can effectively use substitution because these two are equal to each other, right? So once again, there's a lot of possibilities here, but um, I just wanted to go over this way because I think this is more of a way to kind of review what we have done in the past, right? So hopefully that made sense. If you have any questions, of course, leave it down in the comments, but I'll see you next time.